Hello, everyone. Welcome back to today's lecture 9bis of geopolitical applications of notebook code workthrough. So we will have the slides, which covers the global intention of the notebook, as well as one or two blocks of the most important code. And we also have the original code of the notebook that we can go through. So this lecture will be slightly longer than a regular lecture. If if the details doesn't matter as much as the global logic, if you don't only want to understand the global logic, you can directly watch the lecture number 10. Otherwise, let's go through the notebook. Number one is called UN covote construction. What is covote and contravote? So in a UN assembly, with respect to each possible topics, each country can vote yes or no, right? So let's say country I and country J are both voting yes or both voting no to that topic. They will be counting as co-vote. So in this case, with respect to two topics, those country I and J will have two co-votes because there are two times they vote accordingly to each other. So this is co-vote. And we got contra vote, meaning if one is yes, one is no, this count as one contra vote. At the end of the first notebook, most importantly, we will create those no, countries. In details about how the implementation works, we introduce an important concept called trigraphs. A trigraph is three letters for a country because sometimes spelling are different in different sources. Instead of Vietnam, it is Vietnam in a third word in a single word. It can create inconsistency in the data set. So we have to do extra processing to ensure it happens in a consistent way. We use pandas as a notebook to, sorry, we use pandas as a data structure to encode those co-votes and contra-votes. For the next slide, we use a single loop to go through each UN files. We downloaded one by one in the appendix of the source. In the paper, we showed the source and how we access the page and to download them. After downloading all those UN files, we put it in a directory and use a Python loop to go through each of them, counting whether they vote the same. We increment the co-vote. If they are not voting the same, we increment the contra votes. And then at the end, we create them into CSV file. These are some more important part of the first notebook. So this is the first notebook that we can see. Everything is commented in a markdown format, and there are chapters. We set up the environment, we load the data, we standardize the country name. This is a relatively longer paragraph. We create those data frame, we create the summary of co-vote and contra-vote, and then additionally some statistics and visualization. So data setup, we are in an old notebook, we always create a, well, if not all the data are downloaded yet, you can uncomment it and git clone the directory for having this data. We use some variables, so all the variables are explained here, especially the root is the root of directory. And all the data are in those directory, in the raw data of UN. And we use a dictionary to go through those files. We showed an example. So this is an example of how the file works. With respect to the first word zeroth theme, zeroth topic, Afghanistan voted yes. So Y space Afghanistan. A means abstain. Albania abstain this subject, for example. So each country and result are in a line, each line. So we have to go through this line and etc. And by the way, the countries are represented in full letters. So first we have to do those things I mentioned about trigraph mapping. These markdown cells explain this phenomenon of different possible names. Also, AKA is also known as. So we create those variables or functions, as well as some so functions are useful to interact with the dictionary by adding a new country to the AKA, etc. And at the end, we got the UN try. It is a list of all the UN countries in the try format, in the trigraph format. So from the example, these are some text mining. We go through them, we open everything. Um, we store them into trigraphs as well. There are some utility functions to test about the AKA. So I did it manually to for some cases to add those countries' names. So BLR is Belarus, Republic of, for example. We add them to our dictionary. At the end, we do try to AKA. We store them into a JSON file to further use them in other notebooks. So now we are dealing with those consistency names in the country. For data frame construction, there are some explanations about the YAN code. We go through the data. This we have shown you before. We go through each line and count how each countries are voting according to other countries in an easier way. And at the end, we got a data frame with some topics sometimes are not available. At the end, we created those notebook, yes and no, for example. And most importantly, we vote. Uh, we take a look at how many countries are co-voting, how many countries are not co-voting, for example. These paragraphs are just like that. And at the end, we got summary statistic and visualizations. We visualize how many countries are co-voting, how many are contra-voting. So if we do take the co-vote and use a histogram to represent the result, we see that most countries are having these many co-votes. Globally, more or less a centralized trend. For contravolt, it's a bit different though. So for contravolt, we are spiking a lot with respect to the smaller countries. Sorry, smaller amounts of contravolt. We got a lot of country of that, meaning that most of country are like um, voting according to each other. The contravotes are rare. However, there are countries that 40 having more than 40 contravotes consistently. So maybe isolated or internationally, they are having very different opinion than most of the country. In the next paragraph, the results are showing here. These are more details about how the trigraphs are created and also implementation details. At the end, we deal with how organization works. So we got different files in the organization, and we create a dictionary called orgsd. And for each organization, we'll try to write those country down. So at the end, we got those organization D dictionary working here. That's all for the first notebook. For the second notebook, we create a alliance construction overview. So we took those alliance layers, bilateral trade, monetary blocks, military alliances, there are public available data, and we took them, we combine them, we calculate them to output, most importantly, alliances.csv, which is a file of 193 by 193 binary matrix, meaning that for I and J, this case means how many So whether you got more than one alliances in the data set. So whether country I and J have more than one alliances. So for example, the most important cloak, collecting all bilateral trade pairs, we will go through country and countries and whether they are, how to say, appearing in the same data. If it is the case, we will set them in the same agreement set. And we got those economic blocks, military blocks, and then we add them together. At the end, we transform them into a CSV file by checking whether it is greater than one. Let me take a look at the second notebook. So we got different grades. This is a relatively longer one. The same explanation of the trigraphs is given that we mentioned in the first notebook. So we open some dictionaries for especially for treating those trigraphs. We deal with one by one. So EU members we got from the organization D with the EU that we treated in the first notebook. There are some tricks about guest countries. Um, Again, this is still minor details about how trigraphs works here. So none of them are particularly interesting. I will skip them. So some data are coming from here. Again, we could have just sit down and putting one country by one country and key in the country. There are some codes to make it working a little bit faster, but functionally it's basically the same as writing everything down in the Excel format and doing here. So some of the interesting tricks to do to make it a bit quicker. For example, by looking at the string and to see if there are familiar words from the countries and to make it work. So I'll skip all this paragraph. For the monetary and economics alliances are more straightforward. Those are the major international economic blocks. So very straightforward. We took from the internet and we use them directly. And from the text format, I can apply the functions to guess country, meaning that from a string of country, for example, United States of America, and this as a string, when I pass to the function, it will output the trigraph. Sometimes it will fail, so it will be several and nothing. In those exceptions, we do it manually. But for the most case, it will manage to do it correctly. So these are for the economics ones. For military alliances, we got those different alliances with different encodings. Again, we're using the same trick by dealing with by keying in all the country names in the letter format. We try to use the guess country functions to make it work. And then, anyways, at the end, these are processing details. But at the end, we got a Panda data frame writing down which countries are in alliances with which one. So relatively long notebooks and a lot of tricks is to save time, but the concepts are relatively simple. For the third notebook, we took the GDP data that is publicly available. We got we do a simple processing to make it a JSON file and output the GDP data .json. So each country will have a number corresponding to that. It will be the GBP data of, I think it's 2023 of the year that this paper has been created. This is taken from the Work Bank data. So we'll have to parse the file and to go through the data here and finally get a GBP. I will skip this notebook because it's relatively straightforward. Next, it's about the WTO trade data. Um, so we will create some different notebooks. So from the WTO bilateral trade flows, you will have a big CSV file. So these are input balance the export. You will have a country, another country with the number of exports. And one way is to do amount export. So let's say country I export to country JKL, for example, those different countries. And we can take the statistic of this amount, this amount, this amount. Among all the export of the country I, we can create a percentile amongst all the countries and select the countries above those percentiles. So what does that mean by that? So that's a country I export is can be represented as a histogram like this. Let's say this is 10K, 11K, for example, and 40. It means that there are 40 countries that the country I export between 10K and 11K. This can be done. We can calculate that. And we just took the percentile. Let's say this is the 90% percentile. So above 90%, these are the highly cooperating country for the country I. So that's what we do here. The same thing can be do with imports. So on the other way around, we connect it to all the different countries that that export. Maybe I explained the way around, but the other way around of exporting and importing, we switch the rule, but we can still apply the same logic of percentile and create those under export over the percentile or export under certain percentile. Same for the import. We got different numbers because we got different parameters. So we can decide whether to be very strict about the export, 90 percentile, or we can be less strict about it, only take 75 percentile. For example, we tested several numbers to see which one works the best. So we took some balance, we took those CSV file downloaded from the source, the Workbank source, and then we did some processing as well. Some countries are excluded from the data set, and then we do a lot of processing about that. And finally, we found out those percentiles. Let me show you the notebook a little bit. This will be the fourth notebook. Legacy reasons, we called it trades and trans trades. Instead of that, it means exports and imports. So we took the data source. This is called balance export.csv. The result looks like this. This is the raw file. We got different categories from countries to another countries and the amount here, the value. So this is an example to show how a typical row look like. We have to do some pivot table to determine the whole value because the values are subdivided in very different categories. We just want to aggregate everything, so have the countries. So after we do that, we got the pivot table of country to countries export number. And now we have to calculate the percentile. There are some zero trade. We will um, decide them, but they are very limited in our data set. It's not a big issue. We will trim the whole trade dataset metrics to only UN member states. So only countries appearing in both datasets are retained. So in UN nation there may be more, but because this data has only limited amount of countries, we took the intersection of the both case to make it work. So typically PRK, People of Republic of Korea, the North Korea has no data in here as well, so it's showing some problems. Now we are calculating the percentiles of things. We create those trade tables. We create those thresholds. We use those percentile base thresholding method. We got 90, 80 or 90, trade over, 20 or 10, trade under, etc. And at the end, we put the result in the CSV format so we can use them later. Same thing can be done to the imports. I will not show you anything there. It's the same logic. Now, so for the notebook number 5, it is called contra-volt filtering. So the idea we talk about that is we got different co-volt and contra-volt. We want to select taking from the same logic. So let's say for country I, sorry, for the all countries, these are the co-volt distribution. So most countries are co-volt in these amounts between 30 and 40. They are 55 countries, for example. What we want to do is we want to see which countries are extremely co-voting to each other, or some countries are extremely non-co-voting to each other. So based on those percentile. Therefore, we use input and output. The input will be the covolts that we established in previous notebooks, and output will be the covolts, but only over certain percentile or only under certain percentiles. So this is the objective of this notebook. We have to flatten all the covolts. We use a percentile to determine that, and we later visualize the results. So if you look at the code, the logic has been seen. I am showing just you the percentiles. These are distribution of covolts. We can select those 90 and for the lower end, 10 and 20%, etc. For contravolt, we're doing the same thing. We use those threshold-based methods. The query result is 80 and 90, so there are some legacy comments are still 75. We changed that. And then after doing those, sorry, here, co-voting and contra-vote, we apply those map of selecting only those cases and save them into notebooks. So we are saving him here, output to CSV. A little trick using execution to save everything at the same time. But that's the purpose of this notebook. Next one, the friendship enemyship network construction. So we talked about before, we got different criterias. We got the co-vote contra votes, we got alliances, we got an export, and one more criteria, something like that. What we have is two different type of aggregation rules. We got binomial aggregation and trinomial aggregation. Binomials, two of the four criteria are met. Trinomial will be three of the four criteria are met, as well as two different density levels, 80% and 90%. It means that there are four different possibilities for those networks, and it will output eight different files of friendship, enemyship, 80, 90, B, or try. So four different possibility for friends and for enemies. So eight different files. The logic of the notebook is straightforward. We took the notebook we created before and we calculate whether it added more than three or it added more than two to have the result. So something like that. We took these are all notebooks, the same dimension. We add them together. For binomial, the criteria is the result is greater than two. For trinomial, the result is greater than three, and it will be just generating result like this way. For enemy ship, it's same thing. We got the enemy criteria, covolt or contravolt. Covolt under some percentage, contravolt over some certain percentage, not in the same alliances, and balance export are in the lower end. And we create the same results. I will not show you the notebook because the results are basically explained in these two different slides. For the seventh notebook, we scrape the data of the EPI, um, EPI environmental data. You can be accessed to this website. And this is a web scraping code. It is available on the repositories, but I will skip the result here. I'll skip this notebook. There are different parts where we took the URL. We took very details into how the web scraping focused, etc., etc. More interestingly, we look at prerequisite generation for the LGBT. So these are LGBT, environmental, migration, and Palestine Israel. For LGBT legal protections, we go to the websites that are we mentioned in our notebook, and with the same type of web scraping code, we did a part of CSV file for LGBT, CSV file for migration, and CSV file in the environmental. It was in the previous notebook that I just skipped over. But with those notebook prepared, we are now ready to create a prerequisite for four items. Basically, we will took we create what we call a significant choice of those four items, especially for the code of migration, environmental. For those two, since they are numbers, we can took the same idea, a given percentage higher than that or lower than that, we consider them as anchor code prerequisites. For LGBT, we got different criterias. But at the end, we create those prerequisites for the items. For LGBT, we use rule-based anchors. So some example will be if a country is applying death penalty to LGBT relationship, we consider them as an anti-LGBT type of country, are anchored to be that way. And on the other hand, if all the adoptions are legal and marriage are legal, some three or four criteria they are considered as anchored to be pro-LGBT countries. So again, for the environmental and migration are using number index. For LGBT, we got some rule-based way to determine that. And at the end, we create those prerequisites and the real choice. So the real choice of the notebook. I would like to go to the next one as well. Notebook number 9, we got network topology analysis. After creating those network previously, we look at how the network looks like, how to visualize this. So we're using a different, it will be 11 here. We got two different networks. We got network singleton analysis, which take the network. Sorry for scripting. We are taking all this friendship and emission network that we mentioned earlier. We use a function called analysis graph that we write here. Basically count those important statistics, number of singletons, number of edges, what is the largest discrete node, etc. We are using a number representation of the graph, and we create those summary tables to all the no networks. So for the networks, we loop over them, and then we evaluate the graph to generate those summary tables. So this will be the result of the summary table in different friendship network, enemy network, covolt, contravolt. We got everything here. So this is network visualization, sorry, singleton analysis, and also we got visualization, which clearly show how the network, sorry, we're scrolling. We are trying to visualize them and save the files automatically. They are different helper functions, network plot, large component plot, and draw two networks, different little functions to make the visualization looks better. We have the threshold on the network construction, so we want to mark them with special colors. I'll jump over the part of the first part. These are explanation of the different functions. I want to show you the plots. The plot writing here. So when you are running these notebooks um, autonomously, you can uncomment those lines to show the plot of the network. You got different layout possible one. Um, Otherwise, the results are saved and represented in the full paper. For the different trade something networks, it is also possible to do that. So right now we are reading all the CSV file. We create those networks. Sorry, we use the data that we analyzed. So for these networks, we plot them in the batches. I think that's about it. I'll skip over notebook number 9, notebook number 10. So number 10 will create this plot for each and different networks using the library called NetworkX, which is boosted by the matplotlib. For notebook number 11, it is a small notebook of creating those distances. So we mentioned about a primary proximity factor, which is between 0 and 1. 1 means the countries are contiguous, sorry, that are close to each other, next to each other. Otherwise, it will be a fraction, a fraction between two numbers where we take the great circle distance of the country ij, and we took in the numerator the minimum of the distance. So we took a public key data of countries and their distance record with respect to each other. And then we create the metrics. We convert distance to those proximity factors and fill in gaps to each other. Especially we look at whether countries are sharing borderline with each other. If it's the case, it will be just replace with the 1 here. So after that, it will be the net notebook for weighted notebook construction. These are the formula that we talked about in the previous lecture, that we got those GDP, distance factor, and different role. So distance factors are covered in the previous 11th notebook. In the 12th notebook, we we took the previous notebook together and we aggregated the result to have this weight. So at the end, we will have a weighted CSV showing a 193 by 193 weight matrices with the different parameters, row to be considered then, but the weight will be, actually, we will just record this part. This is called the weighted here, which is to be applied to row once we decided to run the model. So for example, we read the GDP data, we create using the formula that we mentioned before, 1 plus the ratio to the power of Dij, the distance factor that we calculated in the notebook number 11. And then we multiply by row or not based on the cases and to have this weighted result. Very quickly, we're going through the notebook number 13. It is the notebook of calling and running all the configurations, the different type. So 2 of density, 3 different levels of row, 4 kappa. Kappa is so kappa is the percentage, 80 or 90, something like that. Oh, sorry. Yeah, it's a threshold range parameter for the significance value. And the density set is the 90 and 80. 80 and 90, it is here. So we got all the parameter settings here. We create a grid of those instances. And for those group, we created a parameter settings and we asked to run those files. The CPP file has been prepared to be running with those different settings. And for the settings, we can take input of the trade, we can take input of the covotes and to run it together. And afterwards, we run the result analysis. And especially we calculate the F1 score function. So we took the real choices, and also we took the choices as predicted by the model, which is output in a different file. We look at those files and we compare those. We use a F1 score to see how much does it matches. And that was the 81%, 80% was the match that we provided before. So in summary, we got 4 different phases. We got the data collection, network constructions, some diagnostics, as well as the model calling and result analysis. At the end of results, we got up to 81% of F1 score at the end. That's all for this relatively longer lectures. Thank you for watching and see you guys in the next lecture. Bye bye.